All right, so if you're deep in your Network Plus studies, you already know the deal. This field is changing, and it's changing fast. So today, we're going to break down the key concepts you absolutely have to nail down for managing a modern network. Let's just dive right in. Welcome to the ASM Educational Center video. Today, we will talk about Section 1.8 from the CompTIA Network Plus exam. Okay, so here's our game plan. We're going to kick things off with a big challenge. What's putting all the pressure on networks today? Then we'll hit the three major solutions: software-defined networking, that whole zero-trust model, and infrastructure as code. After that, we'll tackle IPv6, and then, the most important part, we'll wrap it all up with the key takeaways you'll need for the exam. First up, let's talk about the why. The traditional way we built networks, it was great for a long time. It served us well for decades, really. But now, it's buckling under pressures it was just never, ever designed to handle. And getting your head around this shift, well, that's the key to literally everything else we're going to talk about. So what's the big deal? Why the struggle? Just think back to the old model for a second. You had a physical office, right? Servers were on site, in a closet somewhere. You had a simple firewall at the edge of your network, and that was that. It was predictable, it was static. Well, that world is completely gone, and the network has no choice but to evolve right along with it. And the things driving this evolution, they're huge. We're talking about the massive shift to the cloud, virtualization being everywhere, the desperate need for automation, and of course, the big one, almost everyone working remotely. Now, you combine all that with today's really sophisticated security threats, and that old castle and moat idea of security, it's officially broken. It just doesn't work anymore. Networks today have to be flexible, they have to be intelligent, and they have to be secure from the inside out. Which, naturally, brings us to our first big solution, software-defined networking, or SDN for short. This is all about making our networks programmable, making them agile. So let's pull back the curtain and see exactly how it works. The absolute key concept to grasp here is something called decoupling. See, in a traditional network, every single router, every switch, it has to think for itself. SDN comes in and separates the network's brain, that's the control plane, the part that makes all the decisions, from its muscles, the data plane, which just does the heavy lifting of forwarding traffic. And let me tell you, this separation is incredibly powerful. When you centralize that brain, you get this single, unified view of your entire network. Just imagine, you need to push a new security policy. Instead of touching every device, you push it to hundreds of them instantly from one single dashboard. That is the kind of game-changing efficiency SDN brings to the table for both management and scale. A perfect real-world example of this is SD-WAN. It's taking that exact same SDN logic and applying it to your wide area network, the connections that link all your different offices. So now it can do really smart things, like route your Zoom call over the absolute fastest internet connection it has available. It can automatically set up a device for a brand new branch office without anyone needing to be there. And you can manage the whole shebang from one console. It's just smarter, faster, and a lot of times it's cheaper too. Okay, but what happens when you need to manage this stuff at the scale of a massive data center? How does that work? Well, that's where something called VXLAN comes into play. It's a really cool technology that basically lets you treat virtual machines, even if they're in totally different physical locations, as if they're all plugged into the same local switch right next to each other. This ability to stretch a network and create one giant virtual one, it's absolutely fundamental to how modern cloud environments work. All right, so we've got a flexible network. Check. Now we got to make it secure. And this requires a completely new philosophy. We have to move away from this old idea of just trusting people because they're inside the network. The core idea behind zero trust is actually pretty simple. Never trust, always verify. That's the mantra. Think of it this way. Imagine a high-security building where you don't just swipe your keycard at the front door. Nope. You have to swipe it at every single door inside. The front door, the office door, the server room door, every time. It doesn't matter if you're sitting in the corporate office or at a Starbucks. You have to prove who you are every single time you want to access anything. So how does this actually work in practice? Well, it's a three-step dance, really. First, it authenticates you. It checks your identity, sure, but it also checks the health of your device. Then it authorizes you based on your specific role and policies. And finally, and this is crucial, it grants you access to only what you absolutely need for your job, nothing more. It's a continuous cycle of verify, verify, verify. Now listen up, because this is a huge exam topic. You have to understand how Zero Trust is actually delivered as a product. The big one you'll hear about is SASE, pronounced SASE. It bundles networking stuff, like that SD-WAN we just talked about, with all the security services, and delivers it all from the cloud. Then there's SSE. Think of SSE as just the security half of that SASE bundle. So the main takeaway for your exam, SASE is networking plus security. SSE is just the security. Okay, so our network is agile. It's secure. What's the last piece of the puzzle? Making it consistent and repeatable. And that, my friends, is where automation comes in. Specifically, we're talking about managing our entire infrastructure as if it were just software. So, instead of a network engineer having to manually log into every device and type a bunch of commands, which, let's be honest, is slow and a recipe for human error, Infrastructure as Code, or IAC, lets you define your entire network in code. You literally write a file that says, hey, I need 10 servers, 3 switches, and these exact firewall rules. Then you hit a button, and an automation tool builds it all for you, perfectly, every single thing. And the cool part is, when you start treating your network like code, you get to use all the same awesome tools that software developers have been using for years. You get version control so you can track every single change and roll back if something breaks. You get configuration drift detection, which spots when a device has been changed manually and is out of sync. And you can create safe branches to test new things without breaking the main network. This just brings a whole new level of discipline and safety to network management. All right, let's shift gears for a minute and talk about a really foundational problem. The internet as we know it, built on IPv4, has pretty much run out of addresses. We're tapped out. The long-term solution, IPv6, is here. But the big question for the exam is, how do we get from the old world to the new one? So here are the 3 main ways we make that transition happen. And you've got to know these for the exam. First, there's dual stack. It's the most common approach. You basically just run both IPv4 and IPv6 at the same time on your devices. Simple enough. Then there's tunneling. This is what you use when you have 2 IPv6 networks, but you need to connect them across an older IPv4-only internet. It just wraps the IPv6 packet inside an IPv4 one. And finally, NAT64. Think of this as a translator. It lets your shiny new IPv6-only devices talk to old-school IPv4-only websites. Whew, okay, we have covered a lot of ground. So let's boil it all down to the absolute must-know points for your Network Plus exam. Think of this next part as your personal cheat sheet. First things first. For the exam, you have got to connect the concept to the application. The concept, SDN, which is all about separating that control plane brain from the data plane muscle. The most common application they'll throw at you, SD-WAN. It uses that very same principle to make your wide area network way smarter. Number 2, you need to watch out for this because it's a super common point of confusion and the exam loves to test it. ZTA, Zero Trust Architecture. That's the philosophy. Never trust, always verify. SASE and SSE, on the other hand, those are the products, the solutions you buy to make that philosophy a reality. So remember, one is the what, the others are the how. Third tip, when you see infrastructure as code on the exam, your brain should immediately go to the business benefits. They're not just going to ask you what it is, they're going to ask why you'd use it. So you need to remember version control for rolling back mistakes, drift detection to catch unauthorized changes, and automation for building things fast and, most importantly, consistently. And finally, number 4, be ready for scenario-based IPv6 questions. They're going to describe a network situation, and you'll have to pick the right tool for the job. So if the scenario talks about a long-term gradual upgrade, your answer is probably dual stack. If it's about connecting 2 IPv6 islands over an IPv4 network, you're looking at tunneling. And if the problem is letting new clients talk to old servers, well, that's a job for NAT64. So let's just end on this thought. As networks literally become code, and as trust becomes this explicit, constant verification process, what does it even mean to be a network engineer in the next decade? The future isn't just about plugging in cables and configuring boxes anymore. It's about being an architect, a programmer, a security strategist, all rolled into one. So the real question to ask yourself is, are you ready for that future?
That wraps up section 1.8. Make sure to check out the next section as we continue exploring the topics in the CompTIA Network Plus exam by ASM Educational Center.